Essentially, this talk is about what DB offers when you deal with data and modeling tasks. So when you build recommender systems, when you build machine learning systems, often you don't think around the concept, the concert of things around them. But what this talk, hopefully you should take away from it, is that DuckDB offers you a lot more than simply just running queries, and it helps you move fast. Okay, cool. So what are recommenders? The idea is for you to just get a very high level of what these recommenders do, but the theory and the practice of recommenders are similar to any algorithm or any machine learning model that you've dealt with or you've seen in the wild. You have seen recommender systems in your Netflix, on Amazon, TripAdvisor, or anywhere you go to where you don't search and then they seem to know what you want. Basically, that is a recommender. So what they do is they learn to predict your preferences for profit and for your satisfaction, obviously. And to do that, they tap into multiple sources of data. It could be your history when it's available. It could be the product catalog, what they do have in stock. It could be the context. Maybe it's just the news. For example, in Ireland, maybe it could be about the Olympics or housing crisis. But that piece of information feeds into the machine learning model. And then obviously a set of business rules. So let's say you're recommending books. You wouldn't want to recommend pornography to kids, right? So that would be like a business rule that you plug in. You take all of this, pack them into a single solution, plug them into the machine learning model, and out comes your preferences. These preferences in most cases are just a series of rules. This is what you should take away about a recommender system. They learn patterns and rules. And in doing that, the recommender system is able to tell what you like from what you do not like. When we say things we like, internally we call those positive samples, and it's important that you remember this name because I'm going to use it going down in the next few slides. And these positive samples are things you have done, so it's easy to gather. You've clicked on a hotel, we know you like it. You've watched this movie, we know you like it. On the other hand, there are negative samples, and you need to have that at hand, but it's very scarce. The fact that you did not watch a movie does not mean that you do not like that movie. It simply means you did not watch it, right? So we call these negative samples, and you need them. And if you remember the movie or the TV show, is it Silicon Valley, where Jin Yang had like the hot dog app, right? And it was just a predictor to say, this is a hot dog, this is not a hot dog. So I'm sure she passed a lot of hot dogs through it. And then any other thing that is not a hot dog would be the negative samples for that. So keep that in mind. Now, where to find these negative samples is still a subject of debate. It's still a very open research question. And I'm going to tell you how we did it in DuckDB. And this is just a very naive implementation, but it works. So beyond negative samples, there are lots of challenges when it comes to building a machine learning model, especially recommender systems. And I want you to think of a context where you have multiple collaborators working on the same project, right? As opposed to one person hiding off somewhere and building this machine learning model. What you start to see is that you need to collaborate, right, between the contributors to that particular project. And when you have more contributors, the expectation is that you move much faster. But too many cooks will spoil the broth. So there needs to be a way that you facilitate these contributions without one stepping on another person's toe. But what's even most important is if one person succeeds on a team, then their success should be reproducible across board, right? So we need a standard to replicate experiments. That's also a challenge when you do that, because you can't say it works on my machine and that's okay. But what's even most important is when you build it, wherever you build it, it should be easy to get it into production. So where possible, you want your development environment and the pipelines to mirror what you could have in production. So these are just some of the challenges that comes into play when you think around collaboration. The other challenge is scalability. Imagine a situation where you don't have PySpark or Spark because, for whatever reason, and it's 2024, so everybody's embracing the modern stack, DuckDB and the others. Why not? Scalability becomes a concern because there's always more data than you can feed your model. Most of these models, the more data you give it, the better they are. So you have to figure out how to deal with scale problems. And what we have at the moment is that vertical scaling allows us to add more RAM, and it's actually cheaper. There was a previous talk here where someone mentioned about horizontal scaling. It's actually cheaper for you to vertically scale by adding more RAM than for you to provision a new machine, because once you provision a new machine, there's a cost involved in running that, and all that kind of stuff on there. So there's a limit to vertical scaling yet. And a single machine would go a long way. So how can we take that challenge and simplify it? But what's even most important is that when you have GPU accelerated models, because most of these models will be GPU accelerated, the bottleneck tends to be them waiting for input IO. That's IO operations, so input operations. When you read data for the models, they just stay idle until they get that data. So we need to ensure that there's a neat pipeline that just kind of feeds that model really fast. But from a team perspective, if the team can move much faster, if I can retrain my model on a daily basis, that is good for the business, right? So it means that we can do more experiments and hopefully get to a better product at the end of the day. This is where DuckDB comes into play. All those problems, all those challenges, DuckDB. So I'm not going to sell DuckDB beyond that, but let's just say that it works for us. And again, there's a disclaimer here, so I'm not representing my company, but let's just say that it does work for whatever context I'm working with. So in terms of collaboration, this is the first problem I mentioned. To collaborate without friction, to be able to work with other people, you need to have a concept of a data set. Because if you imagine that when you run an e-commerce business, the data is always increasing. Some of them are becoming stale, some of them is becoming new. So you need to have snapshots of your data, what we call a data set. So you need to have that handy. Also, when you collaborate with people, you want to give each contributor the flexibility to go off and create their own features. Features are essentially the aspects or attributes of data that goes into these models. But what's most important also is that when you have collaborators, some of them would leave, new ones would come. So you need to have the flexibility to allow other people to contribute to your project without much friction. And with DuckDB, we're able to adopt a strategy that allows us to pull as much data as we need and then enable all these requirements. And I'm going to talk about that. So imagine a situation, and this would be a typical setup for an e-commerce or an ML team in an e-commerce setup. I'm just trying to get this to work. Okay, no pointer. It always starts with your database, and this would be a collection of records containing all those sources of data I talked about, which is the context, the user histories, the business rules that would reside in some database, probably in the cloud. What we have when you need to get DuckDB to solve this particular problem is a concept of a data spec, which is just a configuration for your data set, and that would contain all the aspects of the data that you want to get. So you can think about it as a range in time. It could be a certain category of customers. It depends on whatever dimensions you want, but think of that data spec as a declarative way of slicing your data, giving you a view into it. We have a query builder essentially that takes this dataset spec and is able to query all the data sources and fetch as much data as we need. And from that comes the data that we use to train the model. So once that is done, the process that orchestrates that saves the data spec and the training data in a cloud storage. And this could be your EC2, it could be whatever cloud provider that you have. What this gives us is a solution to reproducibility and a central source for datasets. So essentially, you've created a new interface for getting your training data, the spec and the associated data, so you could reproduce this on other machines. So when a new contributor joins, what they simply do is query this catalog of dataset specs, okay, using DuckDB, and they can now fetch the training data from the cloud, whatever cloud server, because DuckDB allows you to connect to these cloud providers and pull as much data as you want. The training data is cached locally so that there's no repeated cost in pulling data back. This, if we had MotherDuck, then maybe we wouldn't have worried about all of this, right? But get to MotherDuck. But anyway, so the training data is cached, and from that, we also use DuckDB as a feature pipeline, essentially creating your own features, and that feeds into a PyTorch model for model training. So what DuckDB does here is two things. It serves as a glue, connecting different data sources, but it also serves as a facade, giving us a very neat way to query and access data. That addresses the collaboration problem. The second problem is scale, essentially trying to do more with less. Since most of the models we build are using PyTorch, in some cases there are also TensorFlow models, what you'd find is that for many use cases, people tend to use the map style dataset, which gives you a random access to your dataset, which means you need to have all of that data in memory. But when you deal with larger models, you can't have everything in memory. So what is recommended is to go for the iterator style dataset, and you wouldn't find a lot of this. And it doesn't render well here. I should have chosen a better background. But what we have there is an example from the DuckDB website on how you could use the fetch record batch command. It's sort of there, just over there. That's what you should take away from here. What that command does is when you send a SQL statement to DuckDB, it allows you to retrieve the results in batches. So you just fetch as much as you need, do what you need to do with it, and move on. It's a very handy command, and that's what we'll use to build our iterable data set that allows us to stream data. So at the top there, I'm going to try this. Is the middle, right? Okay. Oh, awesome. Okay, so at the top there, are just kind of things you would do to configure this particular data set, which is what goes into your PyTorch model. This would be very similar to what obtains in TensorFlow. So whatever you take from here, you could apply there. The negative samples, so this method there would be called by the model when it needs data, and then the negative samples are created. And this is where DuckDB plays a very good role. So we connect to DuckDB, we request for the data that gives us both positive and negative samples together, and then we start reading in a loop. And when we read that data, essentially, we could do cheap operations here so that we don't waste the GPU's time, and then we can send it the data that we need, basically. And this happens so fast, thanks to DuckDB. And here, let's just go back a little bit. Notice I'm specifying chunk size. That tells DuckDB the amount of data that you want to get back. So to show you the potency of just vertical scaling and just having a very good machine, this would be a very, it's just the same spec as the machine you said there, about 8. This has about 8 CPUs or so. You can see that increasing the chunk size, tends to move faster because the GPU is hungry for data, so it could process it much faster. The time on the y-axis there is just how long it takes to go through an entire data set. And this results would be from a contrived data set, which is movie length. It's very common to recommend a system domain. So I will share a notebook where you could run this experiment yourself. But what you should take away from this is your RAM kind of determines your speed. And I don't fully agree with this article, but it's a good one to read nonetheless. So there's this article, which is DuckDB is incredibly fast if you have enough memory. I say DuckDB is incredibly fast if you could configure it properly. So yeah, just take note of that and read it. So yeah, DuckDB is also faster than pandas in a lot of operations you do. So when you have a lot of joins, or if you're not familiar with pandas is like a data structure that we use a lot in data science. But if you could do all of those operations in DuckDB, you would be saving a lot of time, and it's also convenient. So with DuckDB taking advantage of the UDF, we're also able to implement negative sampling. And this is how you'd go about doing the negative samples, essentially. So imagine a situation where you have a set of products that is only available in a particular country, and you have all the items that a user had seen previously, and you want to generate negative samples. So essentially, you're trying to find all the items that this user has not seen. That reduces the operation to a set difference operation. DuckDB allows you to specify this operation in Python code, so there isn't too much SQL in there. There's a slight cost to it. And you register this function, this UDF, using the create function command in there. And anytime you write SQL like this, focus on this particular area there, you can call that function. So here is get negatives, and I'm passing the relevant fields in there, and DuckDB will run it in Python. Interestingly, this was really fast, faster than a similar operation in a database, I can't say, but despite it being a UDF, despite it not using arrow format, because I think there are two formats, right? There's either the Python-based one and the arrow-based format. This was incredibly fast. Maybe because the data was local, I don't know, but let's just say it is much faster than some cloud providers. And we did experiment, or I did experiment with a lot of other tools in there. What I gathered was that on a very bad day for a similar operation, DuckDB was at least 10 times faster. And this is me having a very bad day. So we tried this with different data sets, because I mentioned that we have this whole concept of data sets. And you can see that creating negative samples in DuckDB, this would be the same standard of DuckDB. 2 negative samples per positive sample. It goes in about 2 seconds, while in SQLite it's about 5 seconds. And then the data, just kind of like preparing the data for streaming, it takes about 6 seconds. What I mean by that is, I'm just going to go back for a second so that I think I showed it here, this particular statement there, where you say fetch record batch. Okay, that's when the data is prepared for streaming. That takes about 0.6 seconds, while this one takes about 2 seconds. So it's a huge amount of gain that you get. And this 10x difference is a difference between waiting an hour for results and waiting 10 hours for results. So if you think about it, it's not just speed in terms of the algorithm, but it's also the amount an employer is getting, for whatever they are being paid for. So it's a good catch if you want to try it out. And there are some certain tips that I gathered from here, and this would kind of map to what James had talked about earlier. This is the same query, right? Except that this bit has been taken out. So here we have this window functions in there where we're doing sort of a partition by and then an order by. And here we do not have that bit. What I noticed is that there's a little effort involved in trying to tune your DuckDB queries to make avail of the memory resources you have. And that first query, the one with the window functions, this is what it looks like when it runs at first. The CPU usage starts very little. Of course, I can't show, animation, but essentially you can imagine that it keeps growing until it gets to this particular level. The memory just kind of goes really high, and it kind of peaks around 80% because by default, most DuckDB would be using 80% of it. Yes, exactly, good. But without it, it kind of flattens down. This is the same query. So here, without the qualified by, but this is not really to say that you should not adopt DuckDB. It's to say that DuckDB is moving quite fast in terms of addressing most of these concerns. And if you read an article from last year and you compare it to this year, you realize that it's not there anymore. But it's not a deal breaker also because you could rewrite your SQL to avoid all of these concerns. But knowing them beforehand saves you a lot of time. So in there, in the documentation that most of us don't read, there are tips there on setting memory limits. And once you set those memory limits, you avoid the out-of-memory issues. You avoid potentially seg faults, which I've seen one, but then again, I try to push it to the extreme. But at the cost of speed. So the more data, the more RAM you have, the faster it operates. And when you set a limit, it sort of slows down a little bit. So check these two options and set them when you can. And then when you work with a lot of people and there's a lot of setup involved in accessing your data, you should have a single way to initialize your DuckDB connection so that you make sure you clean up afterwards, because it's healthy. It's just data hygiene, right? So having a single connector or a single entry point like this would help, where essentially you're all using similar memory limits, and then you have similar setups, but then what happens afterwards would be dictated by whatever the collaborator wants. It's a very good tip to have. So what I will say is it's been a very enjoyable trip adopting DuckDB. What I'll also say is that it gives you a solution that you could easily productionize. There is a lot of access to help online, but it's the speed that just gets to you. You just get work so fast, and the convenience that you don't have to pull too much data and the cost savings. All of that just kind of makes it a very handy tool for machine learning tasks and recommender systems. So my name is Khalil, and I work for Storytel, an audio publishing house. Thank you.